Asteroids, witnesses of the solar system's past and keys to its future. Asteroids are often described as massive space rocks drifting aimlessly through the universe. But this image is deeply misleading. Asteroids are not random debris. They are ancient survivors, remnants from the earliest moments of planetary formation, dating back more than 4.5 billion years, to a time before Earth, before the Moon, and even before the planets as we know them existed. To understand asteroids is to understand the history of our solar system itself. The birth of asteroids and the early solar system. Around 4.6 billion years ago, the solar system began forming from a vast rotating cloud of gas and dust known as the solar nebula. As gravity caused material to collapse inward, the sun ignited at the center, while the remaining matter began clumping together into small, solid bodies called planetesimals. These planetesimals were the building blocks of planets. Some merged and grew larger, eventually becoming planets like Earth and Mars. Others, however, never completed this journey. Between Mars and Jupiter, the immense gravitational influence of Jupiter, the largest planet in the solar system, prevented these bodies from forming a full-sized planet. Instead, they remained fragmented, orbiting the Sun as what we now call the main asteroid belt. Importantly, asteroids are not the remains of a destroyed planet, as once believed in the 19th century. Modern observations and computer models have conclusively shown that they are primitive material that never formed into a planet in the first place. In other words, asteroids are frozen records of planetary formation, unchanged for billions of years. What asteroids are made of. Asteroids are far from uniform. Through telescopic observations, spectroscopy, and direct sample analysis, astronomers classify asteroids into several major types based on composition. The most common are carbonaceous asteroids, rich in carbon, water-bearing minerals, and organic compounds. These objects are chemically primitive and closely resemble the original material of the solar nebula. Others are silicaceous asteroids, dominated by rock-forming minerals, while metal-rich asteroids contain large amounts of iron and nickel. This diversity tells us something profound. Asteroids preserve multiple stages of planetary evolution, from untouched primordial material to partially differentiated bodies. Meteorites that fall to Earth, fragments of asteroids, provide direct physical evidence of these compositions, allowing scientists to study solar system material in laboratories. Asteroids and Earth's early history. Asteroids have played a crucial role in shaping Earth itself. During the early history of the solar system, Earth experienced a period of intense bombardment known as the Late Heavy Bombardment, roughly 4.1 to 3.8 billion years ago. These impacts were violent and destructive, yet paradoxically, they may have also been essential for life. Carbon-rich asteroids are known to contain water and organic molecules. Isotopic evidence suggests that some of Earth's water and possibly some of the chemical ingredients necessary for life may have been delivered by asteroid impacts. Asteroids were not only agents of destruction, but also contributors to Earth's habitability. Near-Earth asteroids in planetary defense. Not all asteroids remain safely confined within the main asteroid belt. Gravitational interactions with Jupiter and other planets can slowly alter asteroid orbits. Over time, some are nudged onto paths that cross Earth's orbit. These objects are known as near-Earth asteroids, or NEAs. This naturally raises concern, but it is essential to clarify an important point. Large civilization-ending asteroid impacts are extremely rare events. Thanks to modern sky surveys, astronomers have already detected over 95% of near-Earth asteroids larger than 1 kilometer, the most dangerous category capable of global consequences. Smaller asteroids still exist, and while they can cause regional damage, global extinction-level impacts are statistically unlikely. Today, organizations such as NASA's Planetary Defense Coordination Office continuously monitor the sky, tracking asteroid orbits decades into the future. Humanity is no longer blind to the cosmic environment around Earth. Can we deflect an asteroid? For the first time in history, we are not just observing asteroids, we are learning how to interact with them. In 2022, NASA's DART mission deliberately collided with a small asteroid moonlet, successfully altering its orbit. This experiment proved that kinetic impact technology can measurably change an asteroid's trajectory. It was a historic milestone. While planetary defense remains technologically challenging, the principle is now proven. Asteroid deflection is possible. Asteroids in humanity's future. Asteroids are not only potential threats, they are also potential resources. Many asteroids contain water that can be converted into rocket fuel, metals such as iron, nickel, and platinum group elements. In the future, asteroid resources could support long-term space missions, reducing reliance on material launched from Earth and enabling sustained exploration beyond low Earth orbit. Asteroid mining remains technologically and economically difficult, and no large-scale extraction exists today. However, it is actively studied as part of humanity's long-term space strategy. Asteroids as scientific time capsules. From a scientific perspective, asteroids are invaluable. Missions such as OSIRIS-REx and Hayabusa2 have returned pristine asteroid samples to Earth, allowing scientists to study material older than any rock found on our planet. These samples are untouched by geological recycling, erosion, or plate tectonics. In this sense, asteroids are time capsules, preserving information from the very birth of the solar system. Conclusion: asteroids are not random threats from space or meaningless debris. They are true witnesses of planetary formation, contributors to Earth's habitability, objects of scientific discovery, and potential stepping stones for humanity's future beyond Earth. By studying asteroids, we are not only learning about distant rocks. We are uncovering our own cosmic origins and preparing for what lies ahead.